All right, guys, we're back for part two. We remember that we crimped this end on, white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. We checked both sides, making sure the conductor is all the way in, and we made sure the sheath is crimped, and everything looks good on that cable. Now we're doing the same thing on this side. I've kind of pre-prepped this a little bit. Before we put this on, tab side down. We want to take a look at it again. White, orange, orange, white, green, blue, white, blue, green, white, brown, brown. Slide that on. Make sure that you're in all the way with your sheath. And double check that your wire does make it down to the end of the connector so that you're ready to crimp. One thing I want to take note of, and I'm sure that you've read this or you've looked at it already on your homework, we want to maintain the twist rate on category 5 or 5E up to 1/2 inch and 1/4 inch up to 1/4 inch on category 6. This is category 6 cable, and although the connector is only good for 5E, so that means that the total transmission is rated for the lowest category rating. You want to keep them all the same to have that category rating strength to be from beginning to end all the same. If you mix match categories, then the bandwidth is only good to the lowest category rating. But in either case, we are supposed to maintain that twist rate. We can unwind all the twists up to the sheath because by nature of the way that this thing is already built, we will have maintained the twist rate in here up to 1/2 inch, because from here to here is a 1/2 inch. Beyond the sheath, now the twist is still within the cable. The twist rate tells you everything and gives you all of the properties that you need within the cable to have the proper bandwidth. If you mess with the twist rate, you've then messed up the bandwidth, which essentially could screw up the strength of your signal from point A to point B in simpler terms. So now let's see if this thing works. So what we're going to do now is we're going to take our video data voice tool. We're going to pull out the bottoms. All of these are different. This is just one that I happen to have. And you've got a little receiver here. So what I want to do is find the end that is going to receive the RJ45. So if you look here, it's the bigger of the two. I like to pull the tab a little bit so it snaps in. Then, if we're at the work area outlet somewhere, we might have this. And we'd be plugging this into the jack on the wall with a patch cord to go into our receiver. That's snapped in nice. And now what you're going to do is you're just going to hit a button. Right? Really, we could be testing for voice or data. I'm going to hit data in this example. And what we're looking for is a pass. So if you notice, we have a pass. We're testing for data. And all the pairs line up, 1 over 1, 2, 3, 4, 5, 6, 7, and 8. Everything works as it should. In order to turn this thing off, you could simply press voice, and it would turn it off. If I wanted to test for voice, we could hit voice, and you'd notice that we're only looking for 6 pairs, and those 6 do in fact come up if I was just testing for voice. Something on a different note while we're at this video, we have to realize that the only difference between the A scheme and the B scheme, let me show you what I got here. So you notice my left picture in green shows the A scheme. My right picture shows the B scheme. And the only thing that's different is the white green and white orange are swapped. That's all they are. The important thing is right in the middle of the connector is your blue and white blue pair is always going to be in the middle because that's your phone. So if you happen to be carrying phone over your internet or voice over IP, internet protocol, if you're using the same wire to distribute your phone line as your data, it's important to understand that your white blue, blue white pair are always going to be in the middle. So that's something that you're going to learn in the book, and you'll understand that a little more fully. That's where our dial tone would be if we had the old conventional phone line. So A and B scheme, we just made a patch cord, and it looks good, works, no errors, and that's what you're going to be doing in labs. So hopefully you got something out of this video, and I will see you at the next one.